Hello students! In the previous video, we learnt about these 6 trigonometric ratios. I told you that sine function, abbreviated as sine, is the ratio of opposite side to the hypotenuse. Similarly, cosine function, abbreviated as cos, is the ratio of adjacent side to the hypotenuse, and tangent function, abbreviated as tan, is the ratio of opposite side to the adjacent side. Yes, it is the ratio of sine upon cos as well. And these three, cosecant, secant and cotangent, are the rears of sine, cosine and tangent respectively. Cosecant is cosec, secant is also called sec, and cotangent is also called as cot. Wait for a second. Look at the words tangent and secant in them. What does it remind you of? Yes, exactly. They are related to circles and not triangles. Am I right? Yes. So these names relate a lot more to circles than triangles. So how come they are used in branch of mathematics, that is trigonometry, that deals only with triangles? Well, to answer this question, let us consider one circle with a center O and a radius of 1 unit. Wait, draw this circle on a Cartesian plane or coordinate plane like this. Observe that the center of the circle is same as that of the origin point of this Cartesian plane. This is the x-axis which is passing through this diameter, and this is the y-axis which is passing through this diameter. So what are the coordinates of origin here? 0, 0. Yes. And the point where x-axis cuts the circle, it will be 1, 0. As the distance between origin and this point is nothing but radius, which is equal to 1 unit. And the point is on the x-axis. So its y-coordinate will be 0 and thus the coordinate 1, 0. Similarly, the coordinates of these points will be 0, 1 since it lies on y-axis, minus 1, 0 since this is on x-axis but on the negative side, and 0, minus 1 which is again on y-axis but on the negative side. Now let us make one triangle like this in this circle, which is a right angled at B. So the triangle is ABO. Here, this hypotenuse is nothing but the radius of this circle, as you can clearly see it. So its length will be 1 unit, isn't it? Yes. So this angle is the reference angle for us. So let's write it as theta. Now let's write our three ratios here for this triangle and this reference angle theta. So we have sine theta as opposite upon hypotenuse, that is AB upon AO. Cos theta as BO upon AO, as BO is the adjacent side. Tan theta, which is nothing but opposite upon adjacent, as AB upon BO. Now replace the hypotenuse in these equations with 1. We know this is right because hypotenuse of this triangle is 1, which is nothing but the radius of this circle. So I get sine theta as AB, which means that opposite side is equal to sine theta. Similarly, BO, specifically the adjacent side, is cos theta. This is because we have again substituted hypotenuse as 1, and so we have cos theta equal to this length of BO. Now let us put this here. So now you know that values of sine theta will give the distance between points A and B, or the length of opposite side. On the same lines, values of cos theta will give the distance between points B and O, since that is the length of this adjacent side. Now what about tan theta? To know this first, let us draw a tangent to this circle at the point A. Yes, where one of the vertex points of this triangle is touching this circle. Recall that a tangent is a line that touches a circle at one point. It lies outside the circle and cuts the circle at only one point. It will be something like this. Let us say this point is P, where tangent cuts the x-axis. Now the distance from this point A to P is nothing but tan theta. So now we have three ratios with respect to the circle, right? Exactly. Sin theta is this distance, that is of opposite side. Cos theta is this distance, that is of adjacent side. And tan theta is this distance, that is distance on the tangent of the circle. Now what about these three inverse ratios? Let's see sec theta. It is an abbreviation for secant. And then what is a secant? Recall that secant is a line that passes through the circle and intersects it at 2 points. So can you figure out the secant here? Pause the video and try to figure it out. Yes, this x-axis acts as one secant. It intersects the circle at 2 points like this. And this y-axis is the other secant which intersects vertically to the circle like this. So then what is sec? Just like tan theta was this distance, sec theta is the distance between these 2 points. Point O, which is the origin and also the center of the circle, and point C, which is the point where tangent meets this secant on this x-axis. Remember, it is on x-axis. Okay, now what about cosec and cot? Yes, this distance is cot theta and this distance is cosec theta. Well, if you look at the figure very carefully, even the cosec theta is on the secant of the circle, which is why it is related to secant. Look at this y-axis. Isn't it a secant? Yes, it is. I just said that it intersects the circle at these 2 points. Thus, cosec is the distance on this secant from the origin to the point where y-axis intersects the circle. Then what about cot theta? Yes, this distance between the point where the hypotenuse touches the circle or a point from where tangent is drawn towards the y-axis is called as cot theta. So note two things very clearly, students. Cot theta, cosec theta and cos theta are related to y-axis, while sec theta, sin theta and tan theta are related to x-axis. Now imagine this figure without this circle. So this whole side is tan theta plus cot theta. This side is sec theta and this side is cosec theta. This distance is sin theta and this distance is cos theta. So this is how trigonometric ratios are related to triangles and circles. And I hope you get the logic behind using these abbreviations sec and tan for the secant and tangent. What about cot, cosec and cosine? We will see that in our next video.